Today we will be on lecture 5, class and object. We are on the week 5 right now. And so far, no student has logged into this session yet. Because we are primarily a Q&A session, helping students to work on the project and the homework and answer all of the possible questions. So if no one logged in yet, we will get started to go over this week briefly, and then we will end the session. Okay, thank you. So let's get started for this lecture 5, classes and object. So last week we are on the imperative programming paradigm, and then today we are on object-oriented programming, and then class design. We'll be talking about class design, derived class, and the use of class and object. So how to design a class, how to do inheritance, and then how to create object and a class static and the instance attributes. And then we talk about the magic function, the function that every object should have. We call it the magic functions. So these are the typical topics for object-oriented programming. So first, let's have the overview for the object-oriented programming. Basically, it's providing the abstraction for data entity. So initially, we do have the no abstraction on data type. So we only have, in C language, you only have the primitive data type. We have integer characters and then double, okay, and float. Okay, those are the data type in C language. There is no compounding data type except for array. Only array is available. Okay, that's actually what we have in C language. And then gradually the concept of abstraction keep improving. So we start to have the module in C++ language, and we also had a class in the C++ language. So class is a concept that help to organize the data. Why I'm saying about this? That's because originally your data is unorganized. In C language is unorganized. So you have basically you have a X and Y. So if you want to represent the point, the only way that you can do it is you use a structure. Use a C language structure. So C language structure like a record, so it's something like this. But we may have many functions that associate with this object, but those functions actually are independent functions. So you may have a function, but you still need to actually pass the point into the function. So basically, you can have many functions, but those functions are not associated with the data. And that is in C language. So later, when the object-oriented programming language is discussed, they start to bring in the idea of module. And then the module programming that happen in some languages like Ada or some other older language. And then later, when they go to fully object-oriented programming like C++, module change to class. Okay, module class, change the class. So let's talk about class. Class, in a way, is one kind of collection. A whole class of students is actually one kind of collection. Second, class is also have the meaning of classification. Classification means sorting. You actually have data, you classify them into different types. So that's actually because of the idea of the inheritance. You have a base class, you have subclass. So that's essentially your base class is a rectangle class. Your subclass is square class. So square is one kind of the rectangle, but rectangle is not one kind of square. That actually is one, we call it classification. So you use the class to classify your data. So that's actually the initial concept of the object-oriented programming. You have class to provide collection of data. Multiple data field can be collected into a class. Okay. And then also classification. So compared to class in Python, we also have dictionary. So dictionary, you have key value pair, key value pair, key value pair. It's very similar to class. Okay, in fact, the JavaScript object is considered to be a sibling of the Python's dictionary. Okay, they actually share similar properties. And JavaScript recently have class, but it's still not very popular. Okay, so class is a concept to help the organization of data. That's actually first, and also it actually helped the readability because of the data abstraction, and also it will make the code reusable. Those are the basic idea of why we need class. So class associated with the data abstraction, data encapsulation, and information hiding thing. So information hiding meaning that you use a black box approach, hiding the function or finding the data inside a module or a function. We call it information hiding. So information hiding and the data encapsulation have overlap, but information hiding sometimes is broader because it including non-class type of the information hiding. Okay. Okay, this chart I think students all know it. So these are the basic concepts of the object-oriented programming, including class, that is the template of the objects, and then object as the data entity units, and then abstraction, encapsulation, private data field, public methods, and then inheritance, polymorphism, readability, and message parsing. Okay, these are message parsing actually is used in concurrent programming. So some programming language like Java do have the message parsing, okay, features. So these are among the features that object-oriented programming supports. Okay, so these are the topic of object-oriented programming, and you can try to understand different topic, okay? So object-oriented programming language, starting from no structure, no data structure, that is basic, then local variable, then that's Fortran. And then later they have global variable, that's a static variable that is in Fortran, Argo 60, and C. Then change to module. Module actually had a compile the idea of namespace, those something like that. And then you in the modular 2, Ada start to have module. And then later start to use the object, like including not only data, but also method in a class. Let's start with the Smalltalk, C++, Java, FL, okay, these different languages. Static are allowing subroutine to return the value from one invocation to another, okay, and while hiding the name in between. Module is a collection of subroutines share some stacks. Okay, this actually is a definition of what is static. Static is some memory that's stored in the global area. So it's not like local variable. Local variable will be gone when your function finish, and static is never gone. Whenever your program got loaded to the memory, they will be existing. Okay. But there is some data that maybe is stated to a function. Okay, let's look at the data stated to a function. So right here, let's call it static.cpp. Okay, C double plus language. Okay, let's write a simple program. So if you declare a variable right here, integer a equals 3, this one is considered to be a global variable, and it is static. So if you actually write here, you write a static, or you don't write static, it's a static variable, and it will be put into the global data area. That's actually is data segment in your OS, and then you create a memory location right there. Okay, that's it, it's static. And what we talk about static is not this static, okay? So right here, you may put a static variable, static like that, okay? And we may print it out. Okay, but sometimes the static we would like to talk about is there may be a function. So let's call this one. Let's call a function called void. Okay, get data. Okay, let's try to call this get data function. So here you may have a static integer x equals 4. And then let's do cout x before. Okay, so here let's do cout. Enter in get data. Okay, and then you print x, and then you x increase, and then you cout x operator. Okay, so you declare a static variable, and this one is a static to function. It is a variable that only this function can see. So right here, if you try to actually cout, this will be illegal. This will be illegal because as you can see right here, the x is undefined. So this is, you cannot see, but it's a static. So this is static variable is static to the function. So this one doesn't work. It's not a global variable. You cannot see it, but you can do get data. And then let's do cout some endo, and then get data again. And then cout, and then enter. Let's get data the third time. And then cout, enter. Okay, so these are running this get data for 3 times. So let's see what happened. So as you can see, initially a equals 3, there's no problem. A is a global variable, that's a static variable. Okay. Now, when you enter into the data before increment, you will get 4, and then you become 5. Then you finish your function, and then you get out, and then you go into get data again. When you enter into there, the x still the same x, after this, you actually increase from here to 6. And when you get out, actually call it again, you actually starting from 6 and go to 7. So this variable is a steady variable to the function. Okay. Any questions so far? So that's actually what static is. You have static variable that may be static to the function, may be static to the GoPro. Okay. So object-oriented programming language, you primarily look into the encapsulation, inheritance, and polymorphism. So first one, you need to know about what is a class, what is an object. Okay, so so an object is a collection of data. Your real data entity is an object, and class is the design that you can use to create multiple instance of the data. Okay, so class is the template or the design blueprint of the instance. So what are objects? Everything in Python is an object. Okay, so everything in Python do have a method associated with it. Even a string, that's also an object. So you need to know what is the identity, what is the type, or what is the value that associated with an object. Okay, these are different basic things about object. So you can do dir to look at the contents of the str. Okay, you can do lower function, upper function. Okay. Okay, you can also check the type of for the object. So Python object, you have account holder, you have account. Okay, so account holder is a person that has surname, prename, ages, profession, and birthday. Okay, and the account has the holder. So holder is a reference type to the holder. Okay. So this one is one account has a order, so it has a relationship. Okay, this has a relationship. Okay, these are the concept of object. And here that is a different topic for OOP. Okay. So class definition, you start with a line of code that's class name. Okay. And put many statement in there. So let's usually use one example to start a class. So that's actually create something called point.py, okay, a point class. So to define a class, you put a class and the name, let's call it point. Okay, that's creating the class. You can pass if you want to do nothing. Okay, that actually the class do nothing. So now you can also do actually define, okay. So this one is a constructor. This one is actually is one kind of a magic function. So the init function is a magic function for the constructor. And then you can do this, you can do self.x equals x, self.y equals y, okay? So self is available for the current object. So current objects x equal x. So this is to create a instance variable, okay? Two instance data field x and y were created over here. So this one is a constructor function, okay? So if here you don't have a cell, then this one will not be the instance function. You have this cell, so this init function become a instance function. Okay, you can also have another function that's called define underline str underline. Okay, this one is also a instance function, and it will be used to provide a toString function in Python language. Okay, the xy may not be the right one. You have to use cell.x and cell.y, but cell.x, cell.y may not be the string type. So you have to convert them to string using str function. Okay, this is the complete call for the toString function that define a point class. So after this, you create a class and you can start to write your code. So you say P1 point 1 is a point of the 3 and 4, and that's to print the P1. So when you use a long list of print P1, the toString function will be used. So this kind of format will be returned. Okay, so you actually create a point of the 3, 4, and then we try to print it so the str function is used. And this is a second magic function we teach so far. Okay. Any questions so far?
We're good.
Okay, so these are the basic definition for class and object. Okay, so the constructor is init function. You actually allow it to be used right here. Okay, so you create a object and then the reference being assigned to P1. Okay, reference being assigned to P1. And that P1 is a reference to an object. So when you do print P1, then you will go to this string function to print out the data in string format. Okay, so the slides do have differences. But if you need a comment, you put triple quote in the class. Okay, that will become a comment. And actually, it will show up in this one will show up in the help page. Okay, let's do this. Okay, let's do this. Let's actually create this one. Let's save it. Let's create here using the triple quote. Okay. And right here, let's say it is point class. Okay, whatever. We write something that is. So we can do save, and then you get out to the terminal, and you start with the Python interpreter Python. So right here, you can do import import what? Import point, because there's a point, the py there, so you import point, okay? So you do see the 3 and 4 because when you import these two function already been loaded, okay? After that, you can do help point. Let's see. Python help for class. Okay. So let's see. So you do help for the point, you would create name for the point is a class. Okay, no. Okay, here you do see the command is right here. That's what I wrote over here. Okay. Any questions so far?
All good.
That actually is document. When you use a triple quote, if you use a single quote or double quote, a single quote or double quote, or some other way to do comments that will not be included in your help page. Okay. Anyway, that's what I want to show you. Okay, so there's an init function. There are several different functions. You have to study how they are organized and how you can use them. Then let's see. Here are the basic important magic functions. When you want to destroy the object, you need to use a delete statement. Okay, you need to use delete statement. So this is a del will delete the object. You remove the object from the heap memory. Okay. Atom and molecule. Okay, this is a chemistry example. So you can create a class called atom, and then there's a constructor. So you need to have a self reference, and then the parameter list for the constructor. Okay. And then you have the init function, simple function. So simple function is a instance variable, okay, instant function. And you will go to the atom to simple table to get the simple for you. So given the atomic number, and then you will return you as simple. Okay. And then there is a reprint function. So reprint function is reprint function or represent function. It is similar to str function, and it will be used to convert a reference to a string. So if there are a str function and there's also a reprint function, which one will be called? Actually, you will call the str function. Okay, so str more important than this reprint, but two functions are similar when you use it. Okay, the molecule function is a collection function. It is including multiple atoms. So it has a data field of the atomic list. Okay. Others are similar. Okay, so we talk about what is class definition and how to use it. Second things that we talk about different type of classes. Some classes is used for main function, some classes used for utility, some parts were used for helper class, some used for program class. Okay, so there are a lot of different type of classes. And the class by itself is a module, okay, and the whole program file is also a module, okay. Utility class usually you are used as a collection of functions for people to use. So next one is a class variable, instance variable. Instance variable belong to each object. So just like what we have created, you will use a self.x equal s, self.y equal y. Okay, this create two instance variable. So you may have a point, and then you create P1. So P1 has two data field x or y. It doesn't belong to the class, it belongs to the instance. So if you create another one, you create a P2 object, the x and y will be different from P1's x and y. And then there are some property you may want to make it as a class variable or even static variable. So you put the static variable just align with the functions and then put it on top of the class definition. That is considered to be a class attribute or a static variable for the class. Okay, so they are global variable, class variable, instance variable. Remember the scope. So here we have a person class, and person and a constructor. Here are many instance variable, and there is an age function. So your main function create a person object, and then change the date. Okay. And then you print every data field for the person. Okay, so this is defined for the class is, I think, okay, not too hard. So there are instance attribute, including the instance function and instance variables. Init function, we talked about it already. So you may have this kind of property statement for the overriding of the function, okay, redefinition. So double underline usually is used for private function, okay. And these attribute setter and deleter, these are the so-called prototype. So this is involved with the function generator. Okay, we'll talk about it later when we have the functional programming. Okay. And remember that Python's class is not a fixed design. It's not like Java. When you design a class, everything will be fixed. In the middle, you can add more data field to it. Okay. So you may have a get attribute or set attribute to get the attribute from a certain object, get a certain data field or property from So get attribute and set attribute are built-in accessor and mutator. Standard accessor and mutator. You don't need to write the getter or setter to do it. And these two actually is a functional generator. Here you will actually create a setter function for the value. So this will be the set value function for it. Okay. Okay, so right here discussing the use of this set attribute and get attribute. Okay. The next one, every object also have function. You have static function that can be class attribute or a static attribute. Okay, class and attribute and static attribute in Python are different things because Python allows you to define in an inheritance structure. It may allow you to have a state class function attribute that belong to a certain class only. That is called a class variable. Okay, so class variable is the data that's owned by itself, not used by its children. Okay, and it's a shared property, so it doesn't belong to the object as well. It belongs to the class. And the static function may be defined right here. And it's not only owned by itself, its children will also see, its grandchildren will also see. That's called static function to the class. Okay. And there are also static methods, okay, for the class. Usually these different methods are used to provide service to the object. So right here we have a span class. There's a number of instance variable. That number of instance variable actually is a class variable, or we call it static variable. Okay, and that actually doesn't belong to any object. So when you access it, you have to use a span dot number of instance. Okay, and there's a function that don't have cell. This one is also considered to be a class function. So when you run it, you need to use the span.print instance to access the function instead of using the instance X to run the function. Okay. But because it's actually a static function, so both using the class dot function name or instance dot the function name should both be working. Any questions so far?
Nope.
So this one without a self is similar to static in Python, in Java. Okay, I'm sorry, in Java. Okay, so that's the class method, static method. Okay. So here, you define a method and you can make it as a class function. Okay. So for in the class design, you may have class method, static method, and instance method. Okay, different level. There is a comparison right here. We don't go into the detail, but just let you know these are available. So that's the class definition. Then instance object will be created by the class. And then there are a lot of objects, and your objects can be created at the runtime. And then it uses the prototype structure so that you can add extra data field to it. Okay, this one, okay. So this is a init str class. We already talked about it before. Okay. Here just listing this different kind of a magic function for you, so you can take a look at it if you have question. Okay. So next one is the decorator. Decorator is a functional generator. You actually kind of overloading the function. Okay. So here we have a decorator called class method. Now automatic make the method as a class method. Okay. This is attributes. Okay, then you can also override in the object's method. Okay. Redefine the function. Using the magic function D under functions. Okay, D is a double. Okay, D means double. Double underline is actually this. This is a double function, double under function. Okay. So double under function usually are private functions. Okay, here one example. So magic function is similar to the double under function. Okay, these are different magic function. I don't go into the detail. So here we briefly go over the object-oriented programming. And any questions so far?
Good.
Any question about a homework or assignment or any question for career? Anything?
Can we talk a little bit about the homework next week? And I think we have a upcoming term project. Not sure.
Project 2.
But yeah.
Project 2 is on try. So try, some student may not have it before. So let's look at the try. Try is a special kind of the tree. Okay. So typically in the coding world, we have a Huffman encoder. And Huffman encoder is used to provide a codebook that you can build on the fly. Okay, that's the purpose of the codebook. So try is another data structure that can use for the codebook. Okay. So given the idea is that you have a root node, and your root node may have 26 child. And let's assume you have A and then B. Okay, so here. So initially you just have a root node, you have nothing. Then that means you have nothing, no child. Then that means you have no word. Okay. Now you may add one word into it. Let's assume that you are adding a B, C to it. So this is root node. So the first letter is A, so you go to A. And then there are 26 child, and then next one you have a B, so you go to B. And then you have C child right here. Okay, so by this way, you can create a tree that can accommodate as many words as possible, but only once. So try by itself is a set. Is a set of words, so it can be used to load the data many words into the tree. It can also be used to actually to store the whole dictionary within the tree. And you don't repeat it because you branch it out 26 ways from A to Z on each node. Okay. So if there is no child in that branch, you will not create a node for it. So that's the idea of the try. Any questions so far?
No.
And later, when you finish the whole try project, we want you to read in a file, that's a text file, and then fit all of the word into the try. And to create a try to become its dictionary. So that's the whole purpose of the project. Any questions so far?
No.
Any other question that I did not answer so far? You're curious about? So
I think
yeah,
that's
yeah,
I think
I
that's pretty much it.
yeah, okay. I briefly go over the concept of a try. And basically, this try project is to build a dictionary so you can load the word into the dictionary. The words from a file. Maybe I think that I'm using some Declaration of Independence or something like that. And you should load basically the word into the dictionary. So let's go back to this whole course of the idea for the programming language, what we want, okay? So basically what we want to learn is the programming language pragmatic. So the pragmatic means mechanism. So what you really want to do is that you want to know how to do language translation from one language to the other, right? That's the whole purpose. So basically, for that to be possible, you need to prepare some input. And then you actually feed to some kind of finite state machine or a translator. And this translator design or finite state machine would depend on a grammar set. So this grammar set defines the definition of the language, and it can be implemented as a translator. Okay, so now your input come in, maybe this language in Java, and it got translated, and then you go to the bytecode. This whole process is programming language things. Okay, now, before we do this kind of translation, you may read in your character strings, one by one character by another character, into your machine. And then your machine may need to tokenize it to break down into words. And then those words you may put into some kind of the word table. And that word table can be implemented by try. So here we are actually giving you the idea of how to build up a simple table. Simple table. The simple table can be a table, can be a try, can be a dictionary, can be a map. Is that okay?
Yeah.
And using a set or a map or any kind of different data structure, the efficiency is different. The load factor may also be different. Okay, the collision may also be different. That depends on which way you do. Okay.
Yeah.
And that project is to teach you the idea of how to use it as a simple table. Okay, use try as a simple table. Any more question? So that is actually a meaningful and useful project. Okay. If no question, that's it for today. Is there any more question? Project, homework, anything?
I'm
I don't
good.
think so.
Mhm.
Yeah.
Okay, no question, that's it for today, okay? If you do have question, you are welcome to send me email or Facebook Messenger's message, and I will guarantee you the messenger will arrive to me faster because I watch it 24 hours whenever I have time, okay? But the email, I would say, may get 1 day or 2 day delay because I'm not reading the email every day, okay? Okay,
Thank
see
you.
you.
See you next week.
Bye-bye.